And this is very important. This is very important to remember the conditions for E-plane, H-plane, and magic T. The procedure is same procedure. But what is the important factor here? The important factor is remembering the conditions for which plane, which conditions we have to follow here. For the E-plane, what are the conditions we are following for the E-plane? What is the first condition we are following? S of 2, 3 equal to S of minus 1, 3. Next, S of 3, 3 equal to 0. This is second condition. The third condition is S12 equal to S21, S13 equal to S31, S23 equal to S32. All these conditions I am substituting in 3 by 3 matrix. After substituting in 3 by 3 matrix, we are getting equation number 5.5. This represents 3 by 3 matrix after substituting the conditions. In S11 place, we wrote as it is. Next, S12 place is also as it is. X13 place is also as it is. Next, which one? S12, S22. Next, S23. In place of S23, what I substituted? In place of S23, 23 plus, I am substituting minus of S13. And next, in place of S31, I am substituting S13. Next one is S of minus 13. Next one is S33 place, I am substituting 0 as per the conditions. After substituting this, I am taking complex conjugate and equivalent to the identity matrix. What is the complex conjugate? S11 star, S12 star. We are writing complex conjugate and both writing beside and doing multiplication. What are the both beside written? One is original matrix, another one is complex conjugate matrix. To this beside, I am writing which matrix? Identity matrix. What is identity matrix? 1, 0, 0, 0, 1, 0, 0, 0, 0. To this, I am doing one row and one column multiplication. First multiplication, which one I am taking? What is the first row here? S11, S12, S13 is the first row. What is the first column here? The first column is S11 star, S12 star, S13 star. These one row and one column multiplying and equivalent to 1. Next row and R2 and C2. After multiplying R2 and C2, what we are getting? What is R2 here? R2 is S12, S22 minus S13. What is here C2? C2 equal to S12 star, S22 star minus S13 star. Multiplied R2 and C2, which is equivalent to 1. Next, third one is R3, C3 and wrote another equation. 3 equations are prepared. After making 3 equations, I am multiplying and writing in terms of determinate form. What is the determinate form of the above equations here? What is the first equation we have? R1, C1 is S11, S11 star. This S11, S1 star, I am representing in terms of modulus. S11 into S11, what we will get? S11 square, which is also attached modulus to this and writing as S11 square modulus. Next one is S12 modulus. Next one is modulus of S13. So the above 3 equations is again framing as equation number 1, equation number 2, equation number 3. After this, from equation number 1, how we got 2 times of S13 from equation number 3, S13 plus S13, what we will get? 2 times of S13 square equal to 1. From that, I brought equation number 4. What is equation number 4? S13 equal to 1 by root 2. Next, first we did 3 combination. What are the 3 combinations is multiplied? R1, C1 is multiplied. R2, C2 is multiplied. R3, C3 multiplied. Next combination I am taking is R3, C1 combination. Which combination? R3, C1 combination. From R3, C1 combination, just take row 3, column 1 multiplication. In row 3, column 1 multiplication, what we got? S13, S11 star minus S13, S12 star equal to 0. From here, I am making S13 common. From this equation, S13 common. What are the terms we left? S11 star minus S12 star is left. From this, I am equating, as from the previous, we got S13 equal to 1 by root 2. So S13 is not equal to 0. Then which term is equal to 0? S11 minus S12 star equal to 0. If these two are equal to 0, we can write S11 equal to S12. We got one condition. Next, substitute phi in 1. What we have to do? Substitute 5 in 1. After substituting 5 in 1, how to substitute what we got in equation number 5? In equation number, we got S11 equal to S12. That one, I am substituting in equation 1. S11 plus, in place of S12, again I am substituting S11. What we will get? 2 times of S11 plus S13. 2 times of S11 square plus S13 square equal to 1. From there, I calculated the value of which one? S11 value is calculated. So as we know that S11 equal to S12 from equation 5, I got S11 equal to 1 by 2. S12 is also we got 1 by 2 only. Next, I substituted all these values in the original matrix. What is the original matrix we have? S11, S12, S13, S12, S22, S23, S31, S32, S33. In that place, I substituted all these values. We got the final matrix. The final matrix is, in the above, we got S33 equal to 0. The final matrix, what we got? The final matrix is here. In the conditions only, we wrote that S33 equal to 0. In the initial, we took few conditions. In that conditions only, we wrote S33 equal to 0. By substituting all these, we got final matrix. The final matrix is 1 by 2, 1 by 2, 1 by root 2. 1 by 2, 1 by 2, 1 by, minus 1 by root 2. Next is 1 by root 2, minus 1 by root 2, 0. This is the concept of which one? E-plane tree. Actually, how the E-plane tree is designed? The original E-plane tree, how it is designed? We have one side port 1, other side is port 2. We have port 3 in upward direction, like this. One side is port 1, other side 2 is port 2. In upward direction, port 3 is kept. This is about E-plane tree. Next, we will discuss the next topic is H-plane tree. The diagram of H-plane tree is port 1 and port 2 is beside. Here we have port 1. This side here we have port 2. 2 are beside. The port 3 is in downward direction. That is the difference between the E-plane and H-plane. In E-plane, the third port is in upward direction, whereas in H-plane, the third port is in downward direction. The first part is port 1, the second part is port 2, the third part we can treat it as port 3. Same way, this one is, we can also represent which is input side, which is output side. Suppose port 1 is input. Inside we are getting data. Port 1 is input. Which is output? Port 2 is output. Port 3 is output. Suppose port 3 is input. Which is in port 3 is input means port 1 and port 2 is output. One more difference is in the diagram, figure number 5.5 and figure number 5.3. The main difference between figure number 5.3 and 5.5 is here it is in closed circuit. In figure number 5.3 is open from port 3 to port 1, port 3 to port 2 is open configuration. Whereas in figure number 5.5, port 3 to port 1, port 3 to port 2 is in closed configuration. It is in closed configuration. Now we will see the derivation part of scattering matrix of H-plane T. In scattering matrix of H-plane T, again I am taking 3 by 3 matrix. That what is the 3 by 3 matrix we have? S11, S12, S13. Next, S21, S22, S23. Next is S31, S32, S33. We have 3 by 3 matrix. Same way how we wrote conditions, the same type of conditions here also I am choosing. The conditions are S13 equal to S23, S12 equal to S21, S23 equal to S32, S13 equal to S31, S33 equal to 0. Substitute all these conditions in where? 3 by 3 matrix we have to substitute. Substitute all these conditions in 3 by 3 matrix. After substitution, the matrix becomes the new matrix we are getting. Next step, what we have to do, make a product multiplication of two 3 by 3 matrix. One is the original matrix, another one is the complex conjugate of the original matrix is equal to RHS side what we have? Identity matrix. In RHS side, we have identity matrix. Same previous, how we did combinations, same type of combinations here we will take. What is the first combination of multiplication we will do? R1, C1. Next multiplication, what we will do? R2, C2. Next multiplication is R3, C3. What is this R? Row wise. What is C? Column wise. Next one is R3, C1. Like 4 multiplications is did and 4 expressions is written here. After writing 4 expressions, writing the 4 same equation in terms of modulus and represented in equation number 1, equation number 2. From third equation, S13 square plus S13 square equal to 1. What it means? 1 plus 1 is 2 times of S13. 2 times of S13 square equal to 1. From that, I am writing S13 value. What is the value of S13 we are getting? S13 equal to 1 by root 2. This S13 equal to 1 by root 2. Keep just beside. Next, another multiplication also I am doing. What is the another multiplication combination? Which one I am taking? Row 3, column 1. Take row 3 and column 1 multiplication. The equation after from the previous matrix. What is row 3? Row 3 is S13, S13, 0. What is column 1? S11 star, S12 star, S13 star. The third term becomes 0 because 0 into S13 star, what it becomes? It is 0. So we are getting only 2 terms. And those 2 terms is equation number 4. From this, I am making common S13. Make S13 common. After making S13, we will get S11 star plus S12 star equal to 0. Here S13 is not equal to 0. Why it is not equal to 0? Previous we got S13 value is what? Previous we got S13 as 1 by root 2. From that, so if it is not equal to 0, S11 star equal to minus S12 star. This one I am substituting and calculating which value? S11. Where I substituted this one, substitute in equation number 1. What is equation 1 we have? S11 we have. In place of S12, I am substituting again S11. As we have square, it becomes positive only. Actually, here we have S1 equal to minus S12. Is it? After making square, this is positive only. Plus 1 by 2. What is S13 value? S13 value equal to 1 by root 2. After making square, S13 value is 1 by root 2. After making square, what I am getting here? 1 by 2 equal to 1. From this, S11 plus S1 is 2 times of S11 equal to 1 minus 1 by 2. 1 minus 1 by 2, how much we will get? 1 by 2. From this, finally, I am deriving the value of S11. What you are getting S11? S11 equal to 1 by 2. Substitute this equation in equation number 2. What is equation number 2? Is R2C2 combination. What is equation number 2? R2C2 combination. In R2C2 combination, S11 equal to S12. We know minus S12. After making it becomes plus only. In place of S12, I am substituting 1 by 2 whole square. What we will get? 1 by 4 plus S22. And we know S13 value. What is S13? S13 equal to 1 by root 2. That after substituting, I calculated the value of S22 combination. S22 combination is calculated. After calculating S22, substitute all these combination in original matrix. What is original matrix? 1, 1, 1, 2, 1, 3. 2, 1, 2, 2, 2, 3. 3, 1, 3, 2, 3, 3. After substituting all this combination, we will get S matrix. This is about which one we discussed? This is about H-plane T. At the next compulsory 3 you learn, you will get one question. E-plane, H-plane and magic T. Next, the third combination we will see magic T. First 2 combinations in E-plane and H-plane, we took 3 by 3 matrix. Whereas in magic tree, I am taking 4 by 4 matrix. Here, which matrix we are taking? 4 by 4 matrix. And here, how the diagram is? It is a combination of both E-plane and H-plane. Actually, this side we have port 1. This side we have port 2. If we are connecting port 3 in upward direction, this is which plane? E-plane. If I connect another port in downward direction, this is H-plane. So this magic T is the combination of E-plane as well as H-plane. Magic T is the combination of E-plane and H-plane. Now here we will see which is acts as input and which is acts as output port. First, here I am taking port 1 and port 2 as collinear arms. We have few conditions. We'll see what are the conditions we have. What is the first condition? The first condition is port 1 and 2 are collinear arms. Then port 3 is treating as a E arm. Port 4 is treating as a H arm. Next, if two waves of equal magnitude are fed to port 1 and port 2. If input is given to port 1 and port 2, where we are getting output we are getting across port 4. This is one combination. If input is giving across port 1 and port 2. Where I am getting output? I am getting output across port 4, whereas port 3 output is 0. This is one combination. Our next combination, suppose input is given to port 4. Input is given to port 4. We will get output across port 1 and port 2. We will get output across port 1 and port 2. Whereas what is the status of port 3? Port 3 is 0 combination. Same way we are checking which is input, which is output in these 5 conditions. After checking these 5 conditions, we will come to the matrix format. What is the matrix? 4x4 matrix. S11, S12, S13, S14. S21, S22, S23, S24. Next S31, like so on, we are writing 4x4 matrix. Again, here also I am concentrating on the conditions. What are the conditions we have? Compulsory, you have to remember these conditions. Based on these conditions only, your derivation will come. What is the first condition? S23 equal to minus S13, S24 equal to S14, S34. Did you observe? 2, 4 equal to 1, 4. Maximum it is matching with 1. Maximum it is matching with 1. Next, S34 and S43 combination is equal to 0. Next one is, in place of S12, I can also substitute S21. In place of S13, S31. In place of S23, S32, so on, we are taking few conditions. I substituted all these conditions in the original matrix. After substituting all these in the original matrix, I got equation number, which equation? 5.27 is got after substituting. Next, after substituting, what is the procedure we had to follow as previous? Multiplication using complex conjugate. What are the multiplications we have to do? R1C1. Next is R2C2. Next is R3C3. Next is R3C3. Next one we have to go for R4C4. Next one we have to go for R4C1. These 4 combination equations we have to write compulsory. These 4 combination of equations is given here. Just show the matrix, which is input output is mentioned, conditions, and next unitary matrix in complex conjugate form. After taking complex conjugate form, equations is written. Here, after writing equations, similar substitution as previous. Similar simplification as previous. Here, from R4C1, I calculated S12 equal to S12 square. Same as following the previous equations, we will get final matrix. Same as previous. Simplification is same as previous. And here I got S11 equal to 0. Next. S22 equal to 0. If you observe, the 2 by 2 matrix is 0. First, S11, S12 is 0. S22, S21, S22 is also 0. Next, last 2 by 2 matrix is also 0. Next, what are the values of S13? S13, S14. S13, S14. Next, S23, S24. S13, S14, S23, S24. I got 1 by root 2, 1 by root 2, minus 1 by root 2, and 1 by root 2. So, this matrix, we will get the simplification of the previous one. So three matrices we discussed, E-plane, H-plane, and magic T, and the applications where we will use this application. It is used to couple the two transmissions of antennas. Coupling means joining the ports. Basically, we have port 1, port 2. To these ports, I want to attach either upward direction or downward direction to connect another ports. We will use these planes, E-plane, H-plane, and magic T. So this belongs to which block? Whatever we discussed is block to very, very important essay question we can guess from unit 8. E-plane T, H-plane T, and magic T. Next, we will discuss, today, we will discuss semiconductor devices from block 4, unit 8. Block 4, unit 8. Here, the topics we have in block 4, unit 8, no derivation part. Only description of the diagram and waveforms. If you write, you will score the marks. Compared to other blocks, we have derivations. Here, no need of derivation parts. Maximum case, we are covering the operation of the circuit diagram and the waveforms we will discuss. In that, what are the topics we will covered in semiconductor devices? In the textbook, we have page number 75, block 4, unit 8. In this page number 75, what are the topics we will discuss? In this, the major topics we can expect as a essay question is tunnel diode, impact diode, and Trapat diode. Three types of diodes we can guess as a essay question. What is the first one? Tunnel diode. Second one is impact diode. Third one is Trapat diode. And the fourth diode which we have is Parrot diode. First, today we will see the tunnel diode. Again, in this tunnel diode, we will get two types of question. What is the first question which is given at the end of the unit? The first question which we will get in the page number 90. In the page number 90 or 84. 84. In the page number 84, regarding tunnel diode, we have two questions. The first question is just to explain the operation and working VI characteristics of tunnel diode is the one question. Another question which we can expect from this tunnel diode is tunnel diode as a microwave amplifier. Only this tunnel diode, we have two questions. Only VI characteristics. Another question is microwave amplifier. First, we will see the tunnel diode configuration. This tunnel diode configuration, this is the symbol of the tunnel diode. In the first slide, what is representing? A tunnel diode. What is a tunnel diode in general? It is same as PN junction diode. But what is the difference between PN junction diode and this tunnel diode? PN junction diode is normally doped, whereas tunnel diode is heavily doped PN junction diode. The main feature of the diode is what? Heavily doped PN junction diode. Tunnel diode is a heavily doped PN junction diode. If heavily doping means, what is the meaning of heavily doped? What about the depletion region? As if we dope heavily, what happens to the current? What happens to the current status? What is the status of current if it is heavily doped?
Depletion layer increases,
No current flows. If it is heavy doped, no current flows and depletion region is increasing. Tunnel diode is heavily doped PN junction diode. This is the major point. And current is decreases as we are increasing high voltage. High to very high voltage. High voltage to very high voltage. And at certain point, again, it acts as a normal PN junction diode. In general, the waveform, how we will observe is initially the current is flowing. Again, it is decreasing. The current is decreasing. Again, what happens? Again, it is increasing. This increasing part, second increasing parts acts as a normal PN junction diode. Initially, no current is flowing. Again, the current starts flow, small current is flowing. After that, it is decreasing. Again, it acts as a normal PN junction diode, which we will observe this one in this, in the Next, due to fast switching or high frequency oscillator and amplifiers, we are doing heavily doping. Due to tunneling effect, charge carriers is moving across the depletion region. For small voltage, easily it will move from P junction to N junction and N junction to P junction. And P acts as an anode, N terminal acts as a cathode in this diagram. In this diagram, P terminal acts as an anode, N terminal acts as a cathode. What is the difference of junction diode? Junction diode, we have only this symbol, not curved. We have positive terminal, negative terminal. This is junction diode. To this junction diode, internal arrows I am keeping. If I keep internal arrows, what it becomes? It becomes tunnel diode. That is the difference between diode and tunnel diode. Next, we will see the working of tunnel diode. In general, just observe the second diagram. In the second diagram, we have valency band, conduction band. The valency band and conduction band, the gap between this one is called as Farabian gap or energy gap. Okay, this is normal PN junction material. If I am taking heavily doped, if I do heavily doped, what happens to the P-type material? Actual, the valency band is this one. The valency band becomes down towards the downward position. Just observe in the diagram, the valency band before doping and after heavily doping. Before doping, this is the valency band. In this arrow we have. If I do heavily doped to the P-type material, what happening to the valency band? It is shifting towards the downward movement to the P-type material. Whereas to the N-type material, what happened to the conduction band? From where the conduction band is started? Here, the red line represents conduction band. But for the heavily doped, what happened to the N-type material? The conduction band is a little bit moving upward direction. Now, so here we have three diagrams. First diagram is general diagram. Second diagram is how P-type material is affecting by doing heavily, and how N-type material is affecting after making heavily doped. This is the diagram and working of tunnel diode. Width of the depletion region depends upon the how we are doping, whether we are doping lightly doped or heavily doped. If the doping level is high, the depletion region is thin here. The depletion region is thin. If the doping level is low, depletion region is more. This same concept I will explain using graphical format. Without applying any voltage. 4 cases I am considering. What is the first case? First case is unbiased condition, means without applying forward bias. That is the first condition. Next, second condition is if forward bias condition is applied, what happened? That is the second condition. Next, we have third condition. What is the third condition? If voltage is increasing further based on the waveform. Next, fourth one is if more voltage is applied. Here, I have VI characteristic diagram is displayed, is it? VI characteristics diagram is displayed. In this is red line. This is the first condition. If initially no current and current is increased. Next, second part, current is decreasing. If current is decreasing, it acts as a negative resistance region. It acts as a negative resistance region. Again, voltage is increasing. What happening? Again, current is increased, but this acts as a normal PN junction diode. So, totally the waveform is explained using 4 points. What is the first point? Unbiased condition or no voltage is applied. If no voltage is applied, what happening to the P-type material and N-type material? At unbiased condition means no voltage is applied. If no voltage is applied, overlapping of P-type and M semiconductor is taking place. Overlap means both regions are very near, as it can jump from one to another. P can jump to N, N can jump to P. When this is possible? When no voltage is applied, which is represented in this diagram, and no conduction is taking place. See, initially no current. In this you have second figure, graphical figure. In graphical figure, current flow in the flow outleda. No current is flowing because both are very near. Easily can jump from P to N, N to P. No easily overlap, no current is flowing. See the second one. Here what is written? Because of overlapping of the electrons of conduction band of n-type to the whole side. Here in the conduction band, we have electrons. That is moving towards here. Here this is moving towards here. Holes of valence band of p-type is nearly same level of n-type material. As temperature is increasing, what happens? Conduction band of n-type will overlap with the p-type material. No current is flowing here. Initially very near, easily recombining. The meaning is. Next, second case is in forward bias condition. In forward bias condition, some voltage is applied. When some voltage is applied, that voltage is less than the potential of the depletion region. Whatever the voltage is applying, that is less than the depletion region voltage. Then some of the current is conducts. This current is represented like this. See here. First, initially we have some current. And here in the conduction band, we have electrons that is jumping to where? P region. Electron is jumping into P region. Small amount of current is conducted. That is in forward bias condition. Next, I'm increasing voltage. Up to which level I increased voltage? The voltage is increased up to the peak level. The voltage is increased up to peak level. So some of the here electrons is shown with dark dots. How many electrons here we have? 4. These forces jump to where? P type. 2 electrons are occupied. Previously, only 1 is occupied. As voltage is increasing, few more electrons are occupying into P region. So up to the peak voltage, this one is electron hole recombination is taking place. If beyond I will increase, what happens? Conduction band is moving towards the upward. If it moves towards the upward, it is unable to jump. That is given in the third one. See the third diagram? If increased voltage, if further increased voltage, the current is decreasing. If voltage is increased further, what happens? The current is decreased, which is represented in third one. Next, in the fourth one, if more voltage is increased, it acts as a normal junction diode. It acts as a normal junction diode. The whole concept is represented with this easy method of understanding. And what is this slide represents? What is the region? One region. The region 1. Voltage is increasing as well as current is increasing. The region 1 is called as a ohmic region. What is the region 1 is called? Ohmic region. Voltage is increasing, current is increasing. And next, what happening if I increase the voltage? What happens to the current? Current is decreasing. This decreasing of current is called as a negative resistance region. Next, if I beyond increasing the voltage, what happens again? It is towards increasing to the initial position. That is called as what? Saturation region. So the overall topic is what is tunnel diode, what is ohmic region, what is negative resistance region, what is saturation region. These three you have to explain. This tunnel diode. This is the information has to be covered in which place? This information has to covered in for the first question. What is the first question? Explain the operation of tunnel diode and its voltage ampere characteristics. Question number 1 in 84 means up to this answer you have to explain. Next we have one more question. What is that question? Discuss briefly tunnel diode working as a microwave amplifier. For microwave amplifier, we have another one. Derivation part we will see. After drawing the graph, after drawing the graph, here what I'm doing for taking slope load lines I'm drawing means which points I'm taking a straight line, like how we draw that after in general graphs, slope joining the 2 points and cutting the curve. Same way here for this tunnel diode for microwave amplifier applications, to the same VA characteristics graph. The tunnel diode is useful in which condition? Microwave oscillator. As diode is executing negative resistance characteristics, the region between current and valley point, I am drawing a load lines. What I am drawing here? Load line. What is actually this load line? From the figure 8.2b, I am drawing one line which it will cut. What are the points it has to cut? Which it has to touch? Point A. This is point A. Again, across the negative resistance region. What is this one? Point B. Again, the current is increasing, is it? Across the current increasing, wherever it is touching, we are calling this as a point C. So it is touching 3 points across point A, point B, point C. This, when the load line touches the 3 points, what it becomes, whether it is astable, monostable, or bistable. Where it is stable? From this graph, which points it is stable, which point it is unstable. Across the point A and point C, it is stable. From the figure number 8.3, point A, point C are in stable condition and point B is in which condition? Unstable condition. 2 stable conditions we have and 1 unstable condition we have. So this combination I am taking as a bistable multivibrator. Which multivibrator? This combination is taken as multivibrator, bistable multivibrator. Same way, draw another 2 load lines and one is represented as stable, another one is represented as a bistable, monostable. Total 3 stable states. In general, flip-flop is a multivibrator, which we will call a stable multivibrator, flip-flop. So from this, we are discussing which is stable, which is bistable, which is monostable. After drawing a load line, from A and C positions are stable points, whereas B, unstable point. This load line is called as what? This load line is called as a bistable multivibrator. The first load line point is calling as a bistable multivibrator. Next, same way, draw another load line. You will get which one? A stable multivibrator. Another load line, if you draw, which one you will get? Monostable multivibrator. So we are getting bistable, stable, monostable using 3 load lines. In this diagram, we have 3 load lines like this, which I already wrote one. Is it? Next to the increasing point, this vertical line, one load line is taking this side. Next, another load line is taking this side. Overall, 3 load lines we are connecting to this graph and defining the terms. What are the terms we are defining? Stable, bistable, monostable. Next here, what I am doing? Taking resistor, inductor, and capacitor combination. Here, one capacitor, and here current is decreasing in negative. Did you remember the current is decreasing in negative resistance region? Increasing, decreasing. Current is in negative resistance region. So here the resistor which I am taking is which resistor? Minus Rn. Why we kept minus sign? Because it is a negative resistance region. So the negative resistance region and the capacitor, both are is connected in series or parallel combination. Both are connected in parallel combination. This parallel combination is treated as a tunnel diode. Parallel combination is treated as what? Tunnel diode. To this one, I connected one resistor and capacitor. Signal source resistor, signal source inductor. Signal source resistor is treated as what? Rs. Inductor is treated as Ls. And impedance I am applying across input side. What is impedance? Z of in. Impedance is represented with Z. Across input, what I am writing? Z of in, input impedance. From this, we'll see the derivation part. So, the first two, Rs plus J omega Ls is related to which one? RSLS. RSLS in the series lo undi kada. RSLS series lo undi. The two terms is related to, first two terms is related for the series part. Next two terms, third term is related to which part? Parallel part. First two terms is related for the serial part. Next term is related for the parallel part. After writing this one, we are calculating the frequency. What is the frequency formula? Frequency we are getting 1 by 2 pi RC under root of R square C by L minus 1. Frequency is calculated. After calculating the frequency, so whatever we did is which combination we did? General diagram we observed. Next we will see parallel loading, series loading, which is in the page number 79. Also this topic comes under which one? Tunnel diode as a microwave amplifier application. First we have to draw the general diagram. Next come for the parallel loading. Next is series loading. In parallel loading, what is the difference between the general diagram and parallel loading diagram? In general diagram, we took source as RS and LS. What we took? Source as RS and LS. Here, generator, RG, generator resistance RG, and the resistor across the load is RL. Resistor across the load is RL. Next one is RG. These two are connected in parallel with the tunnel diode combination. This is the tunnel diode combination. To this tunnel diode combination, I connected RS and RL in parallel. Again, here I am calculating what are the terms we have to calculate? Power. Which powers we have to calculate? Output power and input power. What is the output power from this figure? The output power P equal to V square times of RL is output power. Input power is we have to multiply the gain. V in equal to power N equal to V square times of ARL. After getting input and output power, the power across the negative resistance region. The power across the negative resistance region is represented with which one? P of N. Total we have 3. Pn is power across the negative resistance region. One more we have P in, power across the input. Another one we have power across the output. Total 3 powers is there. So output power equal, output power. What is this one? 3. Output equal to input plus negative power. Output means P out. P out equal to P in plus negative resistance region. Total power expression has to write. After writing total power expression, write the gain formula. Gain formula equal to Rn by Rn minus Rn. This is the gain formula. Same way come for the series loading. What is the difference between parallel loading and series loading? In parallel loading, RL is connected in vertical manner, whereas in series loading, RL is connected in series with the RG. This is the difference. This is the difference from the previous one and this one. This is the difference. Similar, what we will do here? After this, finally writing gain formula. What is gain? A equal to RL by RL minus RN. There what we got gain? For this parallel loading, gain is in form of RL. RN by RN minus RL. But here the gain equal to RL by RL minus RN. This is about which answer we have to cover, right? This answer is from tunnel diode as a microwave amplifier. If tunnel diode as a microwave amplifier, you explain about the load line graph. Load line graph, in that we are getting stable, mi-stable, monostable. This point has to mention. After that, general diagram has to write. After writing general diagram, write about the frequency formula. After writing frequency formula, the first general diagram is modified as a parallel loading and serial loading. In parallel loading, input power, output power, negative resistance power. 3 factors we are getting. Same as in serial loading. Input power, output power, but we are mentioning here direct gain formula. This is about tunnel diode as a microwave amplifier. Now next come to impact diode. What is the next topic essay we can expect is impact diode. In this slide, directive only graphs is given, but for derivation part, refer textbook only. Only graph is mentioned in this PPT. Derivation has to collect from the textbook only. Tunnel diode in serial, tunnel diode in parallel combination. And load line diagram. 3 diagrams is mentioned in this. Next, what is the next full form? Which one we have to discuss? The next one is impact diode. In impact diode, here we have many different types of forms. What are the different types of forms? Whether it is N plus P, IP plus, or another type, what we have? Just see the diagram. We have P plus. In this diagram, which format we are using? P plus, N combination, I is drift region, N plus. Is it? Like this, we have many types of combinations. P plus, what is the first combination we are using? P plus, N, I, N plus. Same way, another combination also we have. What is another combination? P, I, N. Another combination is P, I, N. And some other combination, what we have? Only P and N. And some other combination, what we have? P plus, P plus, N minus. This minus I will take as a I. I. Next, another type, what we have? P minus means here I, N plus. Like different types of diodes we have. Different types of diode. What is the full form of impact diode? The full form of avalanche transit time, ATT. What is ATT? Avalanche impact ionization avalanche transit time, full form. What is the full form of impact diode? Impact. From that, first 3 letters is taken, IMP. IMP means impact. Impact, ionization, avalanche, transit, time. Where we are using this one? We are using this one in a microwave oscillator. This is used in the microwave oscillator. It is a solid state diode. What is this one? Solid state diodes. And it is developed for which one? Microwave applications. This is developed for which one? Microwave application. This is used to produce carrier signals. Which signals? This is used to produce carrier signals. Up to what is the frequency it will use? From few gigahertz to hundreds of gigahertz. Example is from 1 gigahertz to 300 gigahertz. Up to this frequency, it will be useful. And this is also called as another name, avalanche transit time diodes. What is the another name? Avalanche transit time diode. And the next one, this is the combination, how it is connected. This diode is useful only for the high frequencies, whereas tunnel diode is a negative resistance. It is used for high frequencies. Especially the feature of this one is it is useful for the high frequencies, and it is manufactured is either of which material? Silicon, germanium, or gallium, indium, INP, gallium arsenide. So this is the material which one we are using is mentioned in this. After this, we will see the characteristics. In characteristics, in textbook, we have N plus P, IP plus. Just check in textbook. In textbook, we have N plus P, I, P plus. You can use either that one or this combination. What is this combination in this slide? We have P plus N, N minus. What is this N minus here? Drift region I. In the textbook, N minus is represented with drift region I. Initially, what happens? P plus N is forward biased. If it is forward biased, what happens to the electric field? Field is increases. Initially, P plus R or N plus P, both. It is which bias? The forward biased. So the electric field is increasing. When we are coming to the N2 N drift region, what happens? It has to decrease. Electric field has to decrease. Field is decreasing, but not it becomes 0. But what happening? It is going constant. Up to which point it is constant? Up to the ending of the drift region. Up to the end point of the drift region, it is constant. After that, what happens? It becomes 0. Actually, the graph is increasing, decreasing, constant, then 0. You have to remember this one. Field, we are discussing about the field. What happening to the field? Initially, field is increasing, decreasing, increasing, decreasing, constant, then 0. This is the very important task in this. From which point to which point it is increasing? Which point to which point it is decreasing? Just observe this one. Here, see in this graph, up to P plus is there, na? Up to that point, what is the status of electric field? Increasing. Up to N, decreasing. Up to N, it is decreasing. After N, when it comes to the drift region, what happening to electric field? Electric field is constant. Up to which point it is constant? Up to the depletion region is ending. After the depletion region is ended, it is immediately going to the 0. And one more thing is voltage and current both are in out of phase here. Now we will see the same explanation in step by step what is written here. What is the first point is mentioned? The diode is operated in reverse bias near the breakdown and N and N minus are completely depleted. N and N minus are completely depleted. Completely depleted means it is going into the reverse bias condition. That is the first point. Now what is mentioned in the second point? Difference in doping between the drift region and avalanche region. The electric field is highly peaked, means field is increasing. What happening to the field? Field is increased. And again, what happening? It is coming to the flat region. Where it is coming to the flat region? In the drift region, it is coming to the flat. And next, what happening? It is decreasing. Overall concept is mentioned in this. And next, come to the next slide. What is the status of voltage and current? If voltage increases, current decreases. If current decreases, voltage increases. Now we will see this one. See here. This one is positive pulse. Is it? Which pulse this is? Positive pulse. This one? Negative pulse. In positive pulse, again the first part is increased. Second part is decreased. When this is decreasing, what happens to the current? Decreasing portion lo chudandamma. Decreasing portion of voltage lo current ఏమవుతుంది? Increase అవుతుంది. Current ఏమవుతుంది? Increase అవుతుంది. Next, reverse లో decrease అవుతుంది. Current decrease అవుతుంది. So this diagram represents voltage and current is inversely proportional to each other. This diagram represents same diagram we have in the textbook also. Both are reverse. This is we had discussed about which diode, ma? We discussed about impact diode. What is the full form of impact diode? Impact, avalanche, transition, time. In this, what are the things we have to explain? Which type of combinations is available is important point. Next, field is increasing, field is decreasing, field is constant in the depletion region or drift region. Again, it is decreasing. Another important point what we have, as voltage is increasing, current is decreasing. These are the major points in this impact diode. Next topic. What is the next topic we have? Next topic is trap-at diode. Still two diodes we discussed. We will complete this one. What is the next one? Trap-at diode. Another one is Barrett diode. Next we will see trap-at diode. Trap-at diode. What is the full form of trap-at diode? Trapped, plasma, avalanche, triggered, transit. What is trapped? TRA, first three letters. Is it? Trapped. Trapped, plasma. Next, avalanche, triggered, transit, diode. Which combination this is available? P plus, N plus, or N. P plus, N plus, or N. And other combinations also we have. In the textbook also the same combination is given. What is the combination? P plus, N, N plus. To this one, I am applying DC supply voltage. To this diagram, which one I am applying? DC supply voltage. DC supply voltage or current meter I am applying. Here either we can correct voltmeter or which meter, ma? Current meter. Either we can connect voltmeter or current meter. To this P plus and N, I connected current meter. Which meter? Current meter is connected. We have two options. Either we can use P plus and N plus, or what is another option we can use? N plus,
P plus.
P plus, N plus, P plus. These combination we can work, and it is operated up to megahertz frequency. It is operated up to megahertz frequency. This is again, this application is used in microwave generator. This is useful in microwave generator applications. And next one is, here the doping is in such a way that the dope is up to pinched through or at breakdown. What is the meaning? Here plasma is produced. Actually here we will call as capacitor is charging and discharging. The term which we will use when diode is in forward bias condition, I will call that capacitor is charging. When diode is in reverse bias condition, what I will call? Capacitor is discharging. When capacitor is discharging, what happens? Plasma region is formed. When capacitor is discharges, plasma region is formed. Again, we had to remove that plasma region. After removing plasma region, what happens? It will works as normally. We will see this one in the next slide. See this slide. See this figure. What happening to A to B in this figure? What happens from A to B? A to B, the diode conducts. Or else I am calling as the capacitor is charging or discharging? Capacitor is charging. Up to which point capacitor will charge? Up to the point B, the capacitor is charging. From B to C, what happens? Capacitor is not completely discharging at a time. Slowly discharging is started. That is represented with which one? Plasma formation. Plasma is formed from where to where? B to C. The plasma is formed. Next from C to D. C to D is also discharging of capacitor. Still plasma formation is continued. Up to B to D. Overall, I will call B to D what happening? Plasma is disformation. Next from D to which point? E. What we have to do? D to F, actual D to F, even that is taking in two phases. Total ekkadi nunchi D nunchi F varaki. Again, that D to F is represented with D to E and E to F. What happening from D to E? D to E, plasma is extracting. What is the meaning of extracting here? Plasma is removed. Removing of plasma. Again, from E to F, if any small amount of plasma means discharging of capacitor, if any small amount is there, even that one also we are removing. From which point to which point? E to F. Overall, D to F, we are removing the plasma. That is called as extraction of plasma. Next, from F to G, what happening? Up to G, current is increased. After removing the plasma, it is again start conducting, charging. Capacitor ఏమవుతుంది ఇక్కడ conduct అవుతుంది. So the capacitor is charging. After capacitor is charging, what happens? It becomes constant. At up to certain level, it is constant. Voltage ఏమవుతుంది? Constant అవుతుంది. Next, in x-axis, what we are taking, in y-axis, what we are taking, in x-axis, we are taking time. In y-axis, voltage and current both, again, up to, from the time period t by 2 to t, the voltage becomes constant. After that, what happening? Second cycle is started. What is the first cycle? Overall, in the first cycle, what we are discussing? Increase, capacitor is charging. Capacitor is discharging. When capacitor is discharging, I am calling as a plasma formation. After plasma formation, extraction of the plasma. If once the extraction of plasma is done, again it is charging. After charging, it becomes constant. Up to certain point, it is constant. Up to here, one phase of cycle is takes place. One iteration. Next, in the second iteration, what happens? Again, from here, charging. It goes on like this. First phase, from here to here, second phase, from there to there, third phase, like one overall process. So in the exam, you had to explain with subheadings, all this. Now, this is explained in sentence by sentence. What is this first paragraph? What is given? Principles of operation. In principles of operation, when high field or high field avalanche zone propagate through the diode and fills the depletion region with dense plasma of electrons and holes that become trapped in the low field region behind the zone. What is the meaning? Charging. After charging, plasma is formed. That is the meaning of this sentence. And the next one. What happens to the point A? Previous figure lo point A అవుతుంది. The starting 0 నుంచి A వరకు చూడండి. జస్ట్ ఇంక్రీజ్ అయిపోయింది డైరెక్ట్ గా. ఇక్కడ ఏ పాయింట్ నుంచి స్టార్ట్ అయింది, అవునా? ఫ్రమ్ ద పాయింట్ ఏ ద కరెంట్ స్టార్ట్స్ ఫ్లోస్ అప్ టు ద పాయింట్ B. That is mentioned in the first one. At a point A, the electric field is uniform throughout the sample and its magnitude is large, but less than the value required for the avalanche breakdown. The current density at this time of point is A. The diode is turned on. At point A, diode is turned on. Next, the charge carriers present are those due to the thermal generation. Some charge carriers is present. So as charge carriers are present, the diode is charging up like a linear capacitor. Diode is charging as a linear capacitor. Now, up to which point it is charging? From the figure, which point?
B.
From A to B, up to A to B, it is charging. From B to D, discharging. The diode acts as a capacitor and it is discharging. This is mentioned in the next one. The diode initially charges like a linear capacitor, driving the magnitude of electric field above the breakdown voltage. When sufficient number of carriers are generated, the particle current exceeds the external current and the electric field is depressed. Depressed means discharging here. Discharged throughout the depletion, and which causes the voltage to decrease. From the B to C point, what happening? Voltage is decreasing. During this time interval, what happens? Voltage is decreasing, current is decreasing. Okay. Sufficiently large for the avalanche to continue, dense plasma of electrons and holes are created. Some of electrons and holes drift throughout the depletion region, and the field is further decreased, and the field is decreasing, and plasma is forming there. What is forming? Plasma is formed. So the voltage is decreased up to which point? The voltage is decreased up to the point T. Next, what happening? After voltage is decreasing from point E to F. From point F to E to F, what we are doing? Removing or extraction of the plasma. Removing or extraction of plasma is taken from E to F. From F to G, the diode is charging again. From diode is charging. At point G, the diode current is goes to 0. From where to where the diode current is going 0? From T/2 to T. In this diagram, we just observe the current is constant. From where to where? From T/2 to T. The voltage or current is constant. Beyond T, what happening? Again, a fresh cycle is started. From T onwards, a fresh cycle is started. So the overall separate subheadings, we have to explain this one. From which point to which point, what is happening? Again, it acts as a normal diode. Therefore, the tripped mode is still a transit time mode. This is a transit time mode. This is used for microwave application process. What is this topic? Tripped diode. Not only in this, we will observe in the textbook also. So the same thing is explained in the textbook. Very easy method. But related topic is in one page. Diagram is in another page. Just observe that one in the textbook.
That only I'm confusing and saying.
In the textbook.
It is flat impact the area below that was
Impact. Which page? Diagram is in which page?
Diagram is
జస్ట్ అదొక కన్ఫ్యూజన్ కాకుండా చూసుకోవాలి. డైరెక్ట్ టెక్స్ట్ బుక్ రిఫర్ చేసేవారు. బట్ ఎక్స్ప్లెనేషన్ ఇస్ గుడ్ ఇన్ టెక్స్ట్ బుక్ ఇన్స్టెడ్ ఆఫ్ పీపీటీ. యూ విల్ అండర్స్టాండ్ వెరీ ఈజీలీ ఫ్రమ్ ద టెక్స్ట్ బుక్. డయాగ్రామ్ వేయాలి. డయాగ్రామ్ వేయాలి, వేవ్ ఫామ్ వేయాలి, ఎక్స్ప్లెనేషన్ రాయాలి. టెక్స్ట్ బుక్ లో ఎక్కడ ఉంది ఎక్స్ప్లెనేషన్? ట్రపాడ్ డయోడ్ దగ్గర ఉంది. దిస్ ఇస్ వెరీ వెరీ ఇంపార్టెంట్. క్వశ్చన్ ఏమొస్తుంది? ప్రిన్సిపల్ అండ్ కన్స్ట్రక్షన్ ఆఫ్ ద ట్రపాడ్ డయోడ్ అని వస్తుంది. పేజ్ నంబర్స్ ఒక్కసారి క్వశ్చన్స్ చూడండి ఎలా రిపీట్ అవుతున్నాయి. ఫ్రమ్ 76 పేజ్ నంబర్. ఫస్ట్ క్వశ్చన్ ఏమో టన్నల్ డయోడ్ విఐ క్యారెక్టరిస్టిక్స్ రాయాలి. డయాగ్రామ్ వేయాలి, టన్నల్ డయోడ్ సింబల్ గ్రాఫ్ వేసేసి ఎక్స్ప్లెయిన్ చేయాలి. నెక్స్ట్ వన్, టన్నల్ డయోడ్ యాజ్ ఎ మైక్రోవేవ్ యాంప్లిఫైర్ అంటే లోడ్ లైన్ డ్రా గీయాలి, జనరల్ డయాగ్రామ్ గీయాలి, సిరీస్ లైన్, ప్యారలల్ లైన్ ఎక్స్ప్లెయిన్ చేయాలి. నెక్స్ట్ avalanche multiplication. This is we can explain this as a short. Next, impact diode. Electric field, how it is explaining. Two graphs చేయాలి. Electric field ఒకటి, voltage versus current ఒకటి. Next చూడండి, explain the operating principle of construction of tripped diode. Next, the last one we have is next one is Barrett diode. What is the full form of Barrett diode? Barrier injected transist time. Barrier injected transist time. This is available in which combinations? The full form of Barrett diode is barrier injection transit time mode. What is the full form? Barrier injection transit time diode. This is used in microwave signals generation. To generate microwave signals, we will use this one. It works based on which one? Thermoionic emissions. Means electrons are discharged when temperature is increasing. When temperature is increases, what happens to the electrons? Electrons is decreasing. Here, diode works as in general avalanche multiplication. What is the meaning of avalanche multiplication? When both recombination takes place, holes electrons recombination అయినప్పుడు it will generate few more electron hole pairs. That is called as avalanche multiplication. So in general, diode works on avalanche multiplication. This Barrett diode works on thermoionic emission. That is the difference. Next, microwave oscillation takes place in Barrett diode due to thermoionic emission. This is one of the important point. Now, which combinations it is available? It is, which combination it is available? Metal and metal. In the textbook, how it is mentioned in the textbook, Barrett diode, whether it is PNP combination, one is PNP combination, another one is PN drift region. I means drift region. PNIP combination. Another one is PN metal combination. Another one is metal and metal combination. Like different combinations is available. This Barrett diode. Next, different combinations is mentioned in this construction. First, basic definition. Next is construction. In the basic definition, this point is important. It is works on which principle? Thermoionic emission principle it will work. Next is construction is given. After construction, working. In working, which type of material is used here? P-type material, N-type material, N-type, P, N and P. This N is treated as I. N nevanukuntunnam? I. So first one is P, N, I, P, drift region. To this one, I applied DC power supply. DC power supply, positive voltage is connected to which one?
P.
Positive voltage is connected to P. Negative voltage is connected to another P. Here, which is forward bias, which is reverse biased? Positive supply with P అనేది ఏమొస్తుంది? Forward bias అవుతుంది. Negative with P వచ్చేది ఏమవుతుంది? Reverse bias అవుతుంది. Now see, the N-type region is larger than P than both P types. So what is mentioning here? N-type is larger compared to P. అంటే ఇక్కడ N-type actually this is drift region, not exactly P region. N అని కూడా చెప్పాం మనం. That is drift region. And another thing is emitter is connected to which one? P-type. Here base is treated as N-type. Collector is treated as P-type. This is we can guess as a short question only. Next, what happening? On which frequency we are operating this one? What frequency we are operating? 25 gigahertz to 90 gigahertz. Frequency is operating for which one? Barrett diode. And which type of material we are using? Gallium and arsenide material we are using. And another thing, emitter base junction is which bias? Emitter base junction is forward biased. Next, base collector junction is reverse biased. Base collector junction is reverse biased. So this is about Barrett diode. In this general construction, general definition, thermoionic emission, how it is constructed, what are the different ways we can construct? Emitter base collector to which one we connected? Next, what are the things has to mention in this? Next, on which frequency it is operating? This is enough for 5 marks answer. If it is in essay question, again we have to draw the VI characteristics, but in our textbook, VI characteristics is not mentioned. This is about Barrett diode. So in today's class, the things what we discussed is, one is semiconductor devices. We can guess one essay question. We'll see in the previous year questions from these which is covered. whatever we discussed, from that we will see what are the things is covered for today class. Check here. Discuss about Barrett diode. Question number 4. Today we discuss. This came as a 5 marks question and write the characteristics of magic tea. So he is not asked about the derivation of magic tea. Characteristics of magic tea and em rayali. Which is input port? Which is output port? We have 4 ports. Port 1, port 2, port 3, port 4. In the textbook, 5 points is mentioned regarding that one. Those 5 parts comes under which one? Characteristics. Which is input? Which is output? 1 and 2 are input. Page number 56 lo 5 points mention chesaru. Those 5 points is comes under characteristics of magic tea. They suppose X matrix and adigar anukondi derivation cheyali. But X matrix is not asked. What is asked? Only the characteristics is asked. Next. Yes, manam today's class ki related chuddaamu. Next essay question lo chudandi. Which is asked? 12th question. What is 12th question? Explain the operating principle and construction of impact diode. Impact diode ante operating construction 3 separate ga mention chesaru chudandi. Operating adigadu, operating principle anta okate, and construction of impact diode and its major disadvantages. What are the disadvantages? Impact diode disadvantages. What we can discuss in impact diode disadvantages means in the textbook, 3 disadvantages, 2 disadvantages is given. What is the first one? Since DC power is drawn due to induced electric current, important efficiency is low. Final conclusion is efficiency is low. In page number 83, why the efficiency is low? Because we are connecting DC power supply. We are connecting DC power supply. Because of DC power supply connection, efficiency is low. What is another point? Noise. It is producing noise due to avalanche process to the high level of operating current. Okay, as avalanche breakdown is or current is flowing in this, it is more noise. So this is we can expect as a essay question, 12th one. And what we discussed from this question paper today is 10th question, essay question, 10th one. What is the 10th essay question? Explain T junction and derive the scattering matrix of H-plane T junction. So what are the factors you have to remember in E-plane, H-plane and T-plane? What is the important task in this? How to learn these 3 answers? What is the important? How to remember for the examination? For the examination point of view, conditions is important. Based on the conditions only, we will derive the derivation. Is it? Based on the condition, we will derive the derivation. We will see another question paper in that which type of questions is covered.
So in H-plane and E-plane, all the conditions are different. It's not even any.
No, not different, same, but science is changing. Okay, example చూస్తాను చూడండి టెక్స్ట్ బుక్ లో ఈ ప్లేన్ హెచ్ ప్లేన్ తీయండి ఒక్కసారి. ఈ ప్లేన్ లో చూడండి
E-plane is 20.